Hello, welcome to this video demonstrating the LT8306 eval board, our new 60-volt low quiescent current no-opto isolated flyback controller. In this video, we will go over the benefits of this solution, how we stack up against our competitors, and demonstrate how to set up the demo board to take an efficiency measurement and measure the output voltage ripple. Let's first start by going over some of the features of the LT8306. The chip has a wide VN range of 4.5 volts to 60 volts. It has a low quiescent current, which coupled with the high operating frequency up to 400 kHz and lack of necessity of a transformer third winding or opto-isolator, leads to higher efficiency designs than our competitors. Unlike our competitors, the part comes in a small 6-lead TSOT23 package and is AEC qualified for automotive applications. These features make the LT8306 ideal for isolated telecom, automotive, industrial, and medical power supplies. Now with that in mind, let's set up the demo board and take some measurements. We are first going to take an efficiency measurement. For the efficiency measurement, we'll first need to connect the power supply to the input of the board. The board has an input voltage range of 6 volts to 36 volts, but we will set the input voltage to 24 volts. I will also make sure that the current limit is high enough so that we do not current limit the output. Next, I will connect my electronic load and multimeter to the output of the board. I will set the load current for 100 milliamps. The demo board can output between 10 milliamps and 2 amps at 11.8 volts and at a switching frequency of 300 kHz. Then, I will ensure that the output is enabled by connecting the enable/undervoltage jumper between pins 2 and 3. Then, I'll enable the power supply and electronic load. Turn on the multimeter, and after doing so, note the output voltage. I will note the load current from the electronic load, the output voltage from the multimeter, as well as the input voltage and current from the power supply. These readings will be used to calculate power and efficiency. Now, I will sweep my load current from 10 milliamps to 2 amps, noting the input and output power. I can then change my input voltage and repeat the process to get data points which will allow me to generate a graph similar to the efficiency graph in the user guide. Finally, I will make sure to disable the electronic load and power supply when I am done. This completes the efficiency measurement. Now, let's change our setup slightly so that we can measure the output voltage ripple. We will replace the multimeter with the oscilloscope. We will need 2 probes and will also need to short C12 between the input and output ground. The rest of the setup will remain the same. We will turn on our power supply and electronic load and verify that the power supply is still set for 24 volts, and then set the load for 2 amps so we can see how the part operates in discontinuous mode. Then, we will take our scope probes and probe 2 different locations. We will use channel 1 for the output voltage and channel 2 for the switch node voltage. To recreate the measurements in the user guide, we will set the time scale to 2 microseconds per division. We will switch channel 1 to AC coupling, bandwidth limited, and 100 millivolts per division. We will switch channel 2 to DC coupling, bandwidth limited, and 20 volts per division. We will set the scope to trigger on the rising edge of channel 2. Now, we are ready to probe the voltage. Enable the power supply and the electronic load. Take the channel 2 probe, connect the ground lead to ground, and probe one of the pins 5 through 8 on MOSFET Q1. This is the switch node. Then, take the channel 1 probe and put the tip and barrel ring on the scope. This helps minimize parasitic inductance in the ground connection, which can cause the ripple to appear larger than it actually is. With this probe, measure across the output capacitor C19 like this. Your scope plot should look like this. With the same setup, we can change the load current to 500 milliamps to visualize DCM with a lighter load, or 0 amps to visualize burst mode with a very light load. Refer to the user guide to see how these graphs should look. That wraps up the bench measurements. For more detailed instructions and information, please refer to the LT8306 product page, which contains links to the simulation models, the datasheet, and the eval board and its user guide. If you have any further questions or require any technical assistance, feel free to reach out to technical support at the link below or the Ask a Question button on the LT8306 product page. Thanks for watching.